All right, everybody, I think I gave it long enough. Um, this is Jim, not Chris. It's Chris up there, but it's Jim Pingle. Giving the hangout this month. Chris is on a bit of a vacation, taking it easy. And we are, this month, going to be covering advanced OpenVPN concepts. That's what we're going to be doing for this month. It's more of a talk. Um, we're not really in some Q&A at the end. We're not going to do a complete walkthrough. There's a lot of stuff I want to get through, and if I were to give a walkthrough, we'd only get through a small fraction of it. But there should be enough in the presentation to sort of extrapolate what you'd have to do to get a full setup. But yeah, it's one of those things that everybody's is going to be a little bit unique, so there's no way we could cover it all in a how-to anyway. We're going to also go over most things I'm going to cover are useful with multi-WAN, but you can use them pretty also in remote access setups or with VPN providers for internet access, things like private internet access, Viper VPN, things like that. Some project notes about what's going on, various ways that OpenVPN's improved in 2.2, how the various types of tunnel networks behave in OpenVPN, different ways of routing traffic across the VPN, and several multi-WAN and redundancy tactics. So a lot of the earlier parts are going to be some basic and fundamental type things to get to what we need to do for multi-WAN and redundancy. First up, the project notes. Hot topic the last couple days is the bash vulnerability. People are calling it shell shock. pfSense, the base system, is not vulnerable. No worries there. A couple of packages, FreeRadius2 and FreeSwitch, did include it. The FreeRadius2 package only included it if you turned on mobile one-time passwords. But we have some new binaries up, so if you uninstall the packages and reinstall the new versions, you should be fine. The FreeSwitch package was not maintained, and nobody was using it that we know of, so we just went ahead and removed it entirely. pfSense 2.15 is out in the last few weeks. Security release has OpenSSL and other fixes. There is a known issue with the menu on Linux wrapping. It's caused by our CSS style sheets and how we specify fonts. There's a bunch of workarounds posted on the forum. Long story short, the way we specify the fonts, it wants Tahoma, and it also says Verdana. And if your system has Verdana, not Tahoma, it's the wrong size and it wraps. You can zoom the view out, put a widescreen theme on there, something like that to get around it. But if we put out a 2.16, if that's necessary, it'll have a fix. But we've already got a fix in 2.2. Speaking of 2.2, we moved it up to beta. It's doing pretty well. We're getting lots of useful feedback in the forum, and we're getting other stuff fixed up. If you want to see that get out faster, just look on our redmine.pfsense.org site. There's a report on the side for 2.2 tickets in a feedback state. Look through those. If anything looks relevant that you're testing and using, just fire off some feedback in there. Let us know if things are fixed and working for you. I've also got the OpenVPN client export update. I'm working on another update. There's some new installers they put out that work with Windows Vista and newer that have a more up-to-date tap driver. The old installers are still going to be there for a while. I know XP is going to die hard, so we'll keep those around. It'll make the OpenVPN client export package a little bit bigger, but a little bit more flexible too. And we do have the hackathon coming up next month. It's going to be October 17th to 20th in Austin, Texas. There are some details on the developer mailing list, which you can find in the archive if you're interested in that. Now let's start off looking at a few ways that OpenVPN improved in 2.2. The clients, your client instances, you can now specify a username and password to save. That's a pretty common requirement now with some VPN providers. They want some authentication on there. And you can also, if they have disabled certificate auth, you can do that too. But the two, they have to work together. If you want to not use a cert, you have to use a username and password. So you can use them both if you want to, but if you want to leave off the cert, you have to put in a password because it has to have some form of authentication. There's now an option in the GUI to select the digest algorithm, similar to the IPsec has. The default in 2.2 is SHA-1 because that's the default in OpenVPN, so don't get confused there. On the older versions, 2.1 and before, it used SHA-1 internally, even though we didn't specify it. So leave the 2.2 GUI on SHA-1 if you, unless you explicitly change it on both sides to something else. It's better if you can on both sides, you put it on something a little bit stronger like SHA-256 or 512. But if you've got one side 2.1 and one side 2.2, make sure you leave that on SHA-1 or manually do it. The client-specific override screen got revamped. There's a lot more fields on there. You can, things that were always possible in the advanced options, but you pretty much had to stuff everything in advanced before. Now you can spread it out. You can add, push routes specific to a particular client. You can put the iRoute networks in there for a site-to-multi-site style VPN, and lots of other fields you can have in there, the DNS and a bunch of others that are client-specific now that are a lot easier to set. We changed the compression settings a little bit. Before in 2.1, you only had the choice of on or off, and it was really unset if it was off, or on adaptive if you had it enabled. And adaptive, what it does is it tests the compressibility of the data every once in a while, and if it thinks you can gain by compressing, it'll turn it on, and if it's not compressing well, it will turn it off. And it can happen dynamically in the middle of a connection, which is handy. But now you can explicitly unset it, turn it full on, full off, or the existing default adaptive. The byte counts on the status page are now human readable. So before it was just a big long string of numbers, but now it'll change it from bits to bytes, megabytes, gigabytes, whatever. And on some instances, you also have the option to disable IPv6 processing if you don't use it. I know a lot of people were a little confused by that. If they didn't have IPv6 settings in there, it would still try and push some IPv6 settings to the clients, but you can stop that now. And there's also a selector for the verbosity level in the logs. The default I think is 3, but you can crank that up if you need to debug something, or if you want even less, you can turn it down. Okay, so a little bit of fundamental about how the various tunnel network styles behave, and this is going to come into play in how we can do some of our tricks later. I know I've listed 4 here, but 2 of them behave alike. There are 3 basic ways that it will behave. In shared key, and there's also just the usual with static key, shared key type setup. You just set 2 IPs on either end. SSL TLS, if you specify a /30 tunnel network. And then there's SSL TLS in ton mode with a /24 or similar. That's typically what you see on a site-to-site or remote access type VPN. And SSL TLS in tap mode or ton with topology subnet, what that lets you do is a little bit fancier, and I'll go into detail on these right now. For shared key tunnel networks, it always uses 2 IP addresses, 1 on each side. You have, the server will get the lower address and the client gets the upper address. It creates a point-to-point interface at the operating system level. So if you were to go in and type ifconfig, you would see, the interface. It would show your IP pointing to the other one, the other side. So because both the client and the server have the same IP addresses, they're bound to each other. They look the same in ifconfig. A lot of things work better at the operating system level. Like you have multicast and broadcast and things like that will work. But what the downside is, only 1 client per server can connect. And so, if you try to connect up 2, one will get bumped off or they'll get the same IP and conflict. Now, and SSL TLS, if you specify a /30 tunnel network, it behaves identically to shared key in this way at the operating system level. So it's really meant for just 1 client to 1 server. So if you prefer to have certificates authenticate, you can do that instead of shared key as long as you use a /30 tunnel network. That's really just a matter of preference and what you like to do. SSL TLS in ton mode with a larger subnet, such as a /24, but it can be bigger or smaller than that, just as long as it's larger than a /30. Use like a 28 or a 25 or a 20 if you want. It allows multiple clients to connect at the same time, so provided they have unique certificates or you have the duplicate connections option on. For peer-to-peer networks or site-to-site, each link gets their own /30 network when they connect, or even remote access. So the server itself uses, the first /30, the next one, the next client will get the next /30, and the next client will get the next /30 after that. So effectively in a /24, you can only have 64 clients. And so, if you need more than that, you'll have to use a bigger tunnel network. And the client subnets are handled inside OpenVPN and not exposed to the OS. So if you look at ifconfig, you only see the first one. With additional clients connected, you never see those IP addresses in the operating system. And OpenVPN, sometimes it won't even respond to ping on them. So it's a lot more restricted in what you can do because you have to rely on OpenVPN's own internal routing and things like that. And because of that, it prevents things like broadcast and multicast from working across the tunnel. With SSL TLS subnet style, it is like tap mode or topology subnet, and which those two behave similarly, except that tap mode passes layer 2 info. The most common use you see for that are people who want to bridge between sites, which we don't recommend doing for lots of reasons, but people still try to do it anyway. The ton method does not transmit layer 2 info. It only does layer 3 and above. To very much oversimplify it, tap mode behaves more like a GIF tunnel. Ton mode behaves more like a GRE tunnel, if you're familiar with those. And topology subnet works like ton mode, where they actually all get grouped into one big subnet. So each client gets one IP address, and there's just one gateway address, and they can all see each other. And you can talk back and forth on the other style as well, but it's all just in one big subnet. It's a more efficient use of IP address space because there's only one used per client. That's why a lot of people like to use it. And in the case of using things like OSPF and such, like you can broadcast and multicast across the VPN. Avahi can work for things like Bonjour and stuff like that. It can have quirks with some clients with topology subnet, especially older Windows clients. You need to watch out for that. With modern clients, it generally is okay, but it's still kind of hit and miss. So before you deploy anything with topology subnet, you definitely want to go through and test that thoroughly. Okay, well that covers the different ways that tunnel networks behave, and now we'll talk a little bit about routing and how these things route. There are 3 primary different ways you can route. There's static routing, which is what most people are doing now, where you put the networks in the remote networks, or you push them in there, and it just gets handled that way. There's also policy routing, which is handled in firewall rules. And then there's dynamic routing, where it's handled by a daemon. The most common one is the Quagga package for OSPF. Now for static routing, this is what pretty much everybody is using. You don't have to worry about it too much. We know it works. It's rock solid. The routes are present in the firewall's operating system's routing table. So if you go to diagnostics and routes, they'll show up there. And the routes are managed by individual OpenVPN instances. So when OpenVPN starts, it'll add those routes. When it stops, the routes are removed. And it's pretty clean that way. The networks are managed using the remote IPv4 networks and IPv6 networks. If you're using an SSL TLS multi-site, you can push to the other ones. You can't push with static key, but you can with SSL TLS. And for SSL TLS and ton mode with multiple sites, you have to worry about I routes, which are the internal, hence the I, routes for OpenVPN and the client-specific overrides. So you have a client that connects with a given certificate common name, and they each have to be unique. And the I routes tell OpenVPN internally which subnet to route back to a given certificate, which it's pretty. It's handy to do for a single setup, but it's pretty inflexible in terms of playing with the routing. For policy routing, the routes are not present in the routing table. If you have routes in the routing table and you policy routing will completely bypass those and ignore them. So you can work around your system routing. You could have a default route in the system and then override that with policy routes. And those routes are managed by PF in firewall rules for the outbound traffic. Inbound return traffic is sort of handled via reply to. Which we'll get into a lot more detail on that later, but generally reply to means if a packet comes in an interface and hits a rule with reply to, it will go back out that interface when it responds, which is a very handy thing to do. Otherwise the traffic would come in from some path and leave by your default route, which you wouldn't want. And with dynamic, the routes are present in the routing table, but they are managed by something else like Quagga or For OSPF, you could probably do something with BGP. I don't know if I'd recommend that, but uh, I've never seen it work. I've never seen somebody try it, but I've seen lots of people do OSPF and it works great. Okay, some of the tricks we're going to do rely on having your OpenVPN interfaces assigned in pfSense, so they actually show up under the interfaces menu. This gives you a lot more configuration possibilities for handling traffic to and from the VPN. Gets you an automatic gateway that you can use, adds a firewall rule tab for rules specific to that VPN, and allows you to use the interface elsewhere in the GUI, things like outbound NAT, port forwards. You could bind a daemon to it. I don't know if I would, but you could try it if you want to. It's not generally useful. Maybe with a VPN provider, if you were allowed incoming traffic, it might work there. To actually do the assignment, you want to make sure when you do that, you are not connected over that same VPN while you do it, or you will get cut off. People hit this, not thinking a few times, just do not do this unless you are connected straight to the GUI, LAN or WAN, not over that VPN. Over a different VPN, sure, but it's something you just want to be extra careful with. And how you actually do the assignment, you just go to the interfaces menu, choose assign, click plus to add another interface, and it'll be in the list. You can pick it like your OVPN S interface or a C interface for client, S for server, and the number should show you the description afterwards. So it should be pretty easy to pick out. Once you hit plus and pick that, you save and apply there, it's going to disrupt that VPN. So from that point on, the communication on the VPN is not going to work until we restart it. But we don't want to do that yet because when you actually go to interfaces and then your new opt interface, when we do this, it would disrupt it again. So we just go to interfaces, optx, which is opt1, opt2, whatever it was that you made in that previous step. Check enable, give it a good name like my VPN, this VPN, the name of your VPN provider, your other site, whatever, just something that's easy for you to determine and connect to, or connect in your head to what it really is. You always set an IP type of none. The IP addresses are all managed by OpenVPN, so never put them here. Just IP type of none and leave it alone, and then save and apply. And then after you've done that, go back to VPN, OpenVPN, find your VPN instance in the server or client tab and edit that and save it, which will completely reapply the settings for the VPN and bring the communication back up. When you add that VPN interface now, if you look under system and routing, you'll see that it did add a gateway for you. It's a dynamic gateway. You don't have to touch the settings on it. You could go in there and disable the monitoring, put a different monitor address, tweak the settings, whatever, but you don't have to make any changes if you don't want to. And that gateway is really handy to use for policy routing. For a VPN provider, for example, you could use that to send only traffic from one specific device over there, like if you've got not that we would condone trying to skirt around regulations, but if you were to have, say, a TiVo device or something similar that you always wanted to send across a VPN so it could reach Netflix, you could do that. That's something you want to do. You can also just pick certain types of traffic, whatever you can match in a firewall rule and add a gateway to, you can send it out that VPN. They can also be used in gateway groups for failover. You can failover either between multiple VPNs, which we're going to get to later, or between a VPN and a WAN, or a mix. I know some people will fail between even between VPN and MPLS, or two different types of interfaces that are private in a VPN. However you need to get your traffic to the far side, you can use it that way. The gateway, because the gateway is there, it will automatically add reply to on the interface tab rules for this particular VPN, which we'll get to in a moment. But whatever you do, do not use it for static routes. So if you, under system and routing on the static routes tab, it will let you select it there, but do not ever use it for that. It is not meant for that. They might work once, then stop, or you'll have all kinds of other problems. If you need static routes, actually code them in OpenVPN in the remote networks or advanced options. Just don't bother putting them there. It's just an accident waiting to happen. The firewall tab that's added by the assignment, like if you go to firewall and rules, you'll get a tab there for the VPN. It allows more fine-grained control of the traffic for this. However, there's a bit of a quirk, which is on the last bullet there. The rules are processed, the floating rules first, and then the groups, which includes the OpenVPN tab, and then the interface tab rules. So if your OpenVPN tab rules have a pass all, these rules will never get hit. So you need to actually fix your OpenVPN tab rules so that they do not match this traffic. So say you've got 2 VPNs and you've only assigned one of them, the rules on the general OpenVPN tab, you need to make sure the source is set so they will match only the sources from your other VPNs and not this guy. Now, if you do match the rules on this tab, it will use reply to, like I mentioned, to make sure your traffic goes back out the way it came in. That's really necessary for any WAN, any multi-WAN type setup. Otherwise, the traffic will come in and go out the default gateway. But with reply to, packet comes in your VPN, it goes back out your VPN. Packet comes in your WAN, goes back out your WAN. And packet comes in WAN 2, it'll go back out WAN 2, as long as your reply to rules are getting hit. With reply to in place, you can also route public subnets across the VPN or port forwards or one-to-one NAT. We've seen some situations, especially with data center relocations and things like that, where if you need to push traffic from one to the other, where your source is going to be something on the internet, so you can't predict the source to accurately route that back. Using the setup like this with reply to lets that work because it doesn't really have to care about the systems routing table. It knows that, hey, that request came across this VPN. When that reply comes back, it needs to go back across that VPN. That makes that possible, and it makes things like those moves a lot easier. I see Carl just asked about one-to-one NAT across the VPN for conflicting LAN subnets. Not in this case, no. This is more for just you could have a public IP at one site that gets mapped to a private IP at a different site. You could get around one-to-one conflicting subnets with one-to-one NAT on both sides or one side. Depends on where the conflict is, but that wasn't something we can talk about that in the Q&A later. To reiterate what I was saying a moment ago, for reply to work, traffic must not match those OpenVPN tab rules. So it's got to fall through and hit your ones on the interface tab. And you can't block the traffic on the other tabs. That won't help. You just need to not match it. So just be really careful with your sources. Or you could assign all of your VPN and OpenVPN instances to different interfaces, get rid of your rules on the OpenVPN tab, and have all your rules for each VPN on their specific OpenVPN tabs. A little bit more work, but you get a lot better control that way if you can swing it. Depending on the number of VPNs you have, that could be a little unwieldy. So it just depends. Okay. Moving on, a little bit more of the meaty section here. I'm going to go into a lot of detail on each of these different tactics that we can do. There's the general ways that we're talking about doing multi-WAN. The first is using multiple remote statements, which is built into OpenVPN. So you have your first server IP specified, and then in your advanced options you put another one. When OpenVPN gets disconnected from one, which is typically about 60 seconds or so, it will try the next one in your list, the next remote statement. So any disconnection that happens, it'll bump you down to the next one. Then if that one gets disconnected, it'll try the first one again. So it doesn't go back automatically. It'll just keep using whatever one it's on until that one gets cut off. And then it'll bounce back to the next one in the list. You can have as many as you want in there. There's no limit to just 2. I think in my examples I may only list 2, but you could have 3 or 4 or whatever. Then the next one is gateway failover, which would be using the interface of the VPN itself would be bound to a gateway group. Also, that just depends on your gateway monitoring. It will fail back immediately when the gateway comes back up, the preferred gateway that is, but the VPN will be disrupted at that time. There's a policy routing method where you can do either connection-based load balancing, which is a big win, or failover. I know of 2 different people that are using that in production very successfully, one of them using 8 different WANs for VPNs and another one using 4, at least I think 4 or 5. There are some smaller cheap lines to go between some sites that have very poor connectivity, and this way they can load balance their VPN connections across there. And even though it's connection based and not aggregation, it still does wonders for their VPN usage. And of course, you can do failover as well. As with the gateway failover method, the time to change depends on your gateway settings, which could be as little as 10 seconds or a minute or more. It depends on how you have it configured. When the first WAN recovers, similar to a regular multi-WAN setup, the new connections will go back to the primary. Existing connections will be left alone on the wherever they were. For dynamic routing with OSPF, very quick time to change. OSPF's hello timers are fairly low, and you can tweak those. So it may only be a few seconds before you can get connectivity, and it does shift the routing from one to the other automatically. There's usually not a perceptible loss of connectivity, especially with the failback. When it fails initially, there could be because it has to detect one is down, but for the failback, it's very seamless. Just to show you a little bit, one of the first tactics will be a single server with multiple WANs, and you can do this for site-to-site or remote access clients. How you do it is you have your server, and notice there's just one server instance. It's bound to localhost, not a WAN, on port 1194, and so each WAN has a port forward that redirects that WAN IP import to localhost on 1194. And you've got your tunnel network and just a sample remote network for this site-to-site. The client for its server IP has your first WAN on 1194 with that tunnel network and the remote network. And then in advanced, we have a second remote statement, which I just mentioned a moment ago. And so if it gets disconnected from here, it will try the next one. If the client has multiple WANs as well, you could do a static route to point WAN 1 of the server out WAN 1 of the client, or in the WAN 2 of the server out WAN 2 of the client, or vice versa. Or you could combine that with like a gateway failover type thing, however you want to do that. But the gist is you got one server bound to localhost, and you port forward into that. So yeah, and that's really useful for remote access VPNs as well. The OpenVPN client export package has support in there. You can choose the hostname resolution dropdown. There are two automatic settings in there, one for by IP, and the other one goes by dynamic DNS. So if you have a dynamic DNS hostname on each of your WANs, it will use that. And this works with not just one port forward on each WAN. It will add remote statements for every port forward it finds that targets that VPN port. It's really good for setting up a remote access VPN where you need to punch out from other networks a lot. You could add, your 1194, maybe a 10,000, a 5060, a 123, a 53, and a bunch of different ports where it'll hop between them all, and eventually it might lock into one that would work from a place where you might have restricted source traffic. Where maybe you're at a hotel or a coffee shop or an airport or something that's really strict on what they let through. So you might have to tweak that a bit. But the port forwards will let you have multiple paths in which you can your client can cycle through to try and work around your other limitations. For a site-to-site VPN, you could use it with the static key or with the SSL TLS site to multi-site style. Similar to what I had in the picture back there, use a second remote statement and advanced options, and you could static route one IP if you want. Another tactic you can do is just with DNS. You could have a dynamic DNS entry bound to a multi-WAN gateway, a gateway group. That way, the dynamic DNS would change from one WAN to the other. I don't know if I do that. That might be a little bit slow to fail over. Dynamic DNS, with DNS TTLs and everything changing, it could add a minute or two to your failover time. But sometimes you don't have a choice, so it's hard to say. Round robin DNS, you could set your DNS up so it would return, one of a couple of IPs, each of your WAN IPs, and you could do it that way. And then, that wouldn't really get you load balancing per se, but it might get you closer to it. Depends on how many clients you have and how often they request the records and whatnot. The next tactic is used for a lot more of the other ones we'll get to. It's having multiple servers on multiple WANs. And one important thing you'll notice is that each of these are on different ports, different WANs, and they have different tunnel networks. And because you now got multiple paths between here, you cannot have your remote network routes in there. So you have to do the routing some other way, whether it's by policy routing or OSPF, something like that. But you need this style of setup if you're going to do something like OSPF or policy routing. Now, You can use this for, like I said, remote access, routing protocol, or policy style, covered later. Only you cannot use it for additional site-to-site because your routes would conflict. You can't have two OpenVPN instances with the same remote networks going in the same place. The first one would work, the second one wouldn't, or vice versa. It would never use both of them, and it couldn't switch. You bind those directly to each WAN, so you don't need to involve the port forwarding or any other weird binding. You have to use different tunnel networks to ensure that they're each separate. The other settings can be the same. You can have the same keys or CA certs, TLS key auth settings, whatever. You just have to have unique tunnel networks. The other stuff can be similar. If the client side only has one WAN, you could use multiple remote statements, or sort of closer to what we had in the start in that first image with the two servers on two different WANs and two different ports, or the same port on two different WANs, but the client, having that in there. That would work for the SSL TLS type mode where you can push the tunnel network, but that would not work for a static key type setup because it would have to know about the different tunnel network to work. Or you can pin up both tunnels, sort of like I had in the previous image. And that there, you in this type of setup, you'd have each of these up all the time. So you'd have these could be on two WANs or one WAN on the client side. It'll work for both ways. So you could have client one to server one, client two to server two. If you use the gateway group method, where you under system and routing on groups, if you've defined a failover group, one on tier one, the next gateway on tier two, you can select that as a bind interface for OpenVPN. However, when it's like that, the VPN is only active on one WAN at a time. So when it fails over, your client not only has to know how to reach the other WAN, but it has to know to try it. Those two can't be independent. If you use the two remote statement method on the client side, but you use this method on the server side, if the client gets disconnected, it will try that second remote statement. That will fail as well, and then have to go back to the first one. So even something as innocuous as just a bump in their internet connectivity could leave your VPN down for 2 minutes. So it's not ideal in the server case. On the client side, it's fine. It's useful for clients with multi-WAN, but it does rely on gateway monitoring, so it can be kind of slow to react. Or we've had some issues with APInger over the years, so some people don't trust gateway monitoring, so it may not be a preferred way to go. If you do use the server method, you would also have to have some way for the client to find both of them. Traditionally, that's either a dynamic DNS on pfSense set to use that gateway group, the same gateway group, so that when the VPN switches to the other WAN, the DNS switches to the other WAN, and they will keep connecting back. Or you could have multiple remote statements, but that had the caveat I mentioned a moment ago, where you can have some significant downtime if you don't careful there. All right, one of these, this one here, we're doing more of these lately because they're pretty handy, especially for load balancing. You can do with policy routing, where you handle the routing and the firewall rules and such. It's load balance. You can do load balancing. It's the only kind that can at the moment. You can also do failover, and you can have one server and one client per WAN. So similar to that last image, you have a separate server on each WAN and a separate client connecting to each separate server. You only need to put in the keys and compression settings and unique tunnel network, no routes, nothing else. You could put the routes on one instance and not the others, because otherwise the firewalls themselves can't reach each other. But if you're only worried about client traffic, you don't have to add any routes whatsoever. You have to assign the VPN interfaces on both sides, the clients and the servers. And then you have to create your gateway groups for desired behavior. So in the gateway groups, you create a new gateway group and add both of your, or two or more of your VPN gateways into that group. So you could either do 2 gateways on the same tier for load balancing, or 2 gateways on 2 tiers for failover. And then in your firewall rules, like on your OpenVPN tab, as I mentioned a bit ago, those rules must not match the traffic because it needs reply to. You could kind of work around that a little bit if you absolutely can't do that with outbound NAT. If you do outbound NAT on the VPN as the traffic leaves, then it would appear to come from the OpenVPN tunnel network on the far side. and so it would send it back to the right VPN that way. Not generally recommended because you lose the source address, but if you're depending on your traffic, it might be simpler to make it work out that way. Or if, in cases of like a VPN provider, you may have to do it that way. You place the rules to pass the traffic on each assigned interface tab. So like under firewall and rules on your tabs for these VPNs, you put them there. And then you add LAN rules to the top of your LAN to match the destination with the gateway group. So you have a rule there that would pass from your LAN to a destination of the remote LAN with the gateway group of your failover VPN gateway, and off it goes. It'll go to the other side. Once you have the reply to, you have to have the LAN rules on your one side to match up with the reply to on the other. The LAN rules will get your traffic to the far side, reply to make sure the far side gets that return traffic back to you. So both sides have to be set up with this, with the OpenVPN rules on their interface tab and the LAN rules set up with the policy routing to get the outbound traffic. So this is really handy lately since we've started doing these. We've had a lot of very positive feedback. I don't know if I would do this over a traditional routed setup in a lot of cases, but it's handy to have in your toolbox. Now, lastly, we're going to get into OSPF and dynamic routed VPN. I'll give a little bit of info on how to set up the OSPF daemon as well. You can use it to link multiple sites together so long as you're careful about your OSPF metrics and paths and things. If you have a central hub and a lot of external sites, it's pretty fine to do. They can all talk to the OSPF instance on the main site, and it's happy. It does require multicast, so as a consequence, it only works with static key or SSL TLS and /30 or tap mode or autonomous topology subnet. It won't work with a site to multi-site SSL TLS, the kind that needs iRoutes. It won't work with that, but the other ones will all work. For the server side, as with the other ones in this area, you have to use 2 unique server instances, one on a separate port and WAN. They have to have separate non-overlapping tunnel networks, similar to the policy routing method. And with this method, you don't want to put any routes in any of the remote network boxes on either side, because OSPF is going to handle all the routes for you. So yeah, don't put anything in there, not even for firewall to firewall traffic. That'll all be handled by OSPF. On the client setup, you set up a client to go with each server, one for each server, or each on a separate WAN. If the client just has one WAN, that's fine. If the client has 2 WANs, you could put one client on each WAN. If the client does have multi-WAN, you could go a little crazy with it. It's probably overkill, but like I show here, you could do 4 connections for 2 WANs on each side, A1 to B1, A1 to B2, A2 to B1, A2 to B2, or you mix it with multiple remote statement method to have one of them hop between one WAN and another. So you can combine this with a little bit with that, but you can't combine this with the policy routing, but you can combine it with the multiple remote statements. I don't know if you'd actually need to do that. I've seen 1 or 2 people do that over the years, but most people don't have to worry about it. You would only really need that if you have several really shoddy WANs on both sides. But if your WANs tend to be fairly stable, it's probably a rare case that you won't be able to get from A1 to B1 or A2 to B2, where you would have to have A1 the other 2, the A1 to B2 or A2 to B1. So that's all up to you, a matter of preference. Personally, I go for just 1 on each WAN on each side. And you need to make sure your OpenVPN tab rules will either pass everything or at least pass OSPF traffic. Because OSPF is multicast, the destination is going to be different, so you can't say from this subnet to that subnet. You could look at what multicast address it uses and do that, but you don't. It's usually easier just to pass the OSPF protocol entirely from the tunnel networks to anywhere. Or you can, and it's good to have ping open up ICMP echo requests opened up in the rules as well if you don't already allow everything. Even before you get OSPF active on there and you just have your VPNs up, just try to ping from the tunnel networks, make sure your VPNs come up, check the OpenVPN status, but you can't do any LAN to LAN tests yet because that'll require the routing daemon to be active. And lastly, here's the setup in Quagga. It's pretty simple, actually. You don't have to assign the interfaces because the Quagga package knows about the OpenVPN interfaces internally. It doesn't need them assigned. You just go into, after you install it from System Packages, it'll show up under the Services menu. You just go to Services and Quagga OSPF, and then you go to the Interfaces tab. And on there, you add each, you click plus and add your interfaces. You add each of your VPN interfaces and just type in a metric. Like your WAN would get a metric of 10, it would be preferred over a second WAN with a metric of 20. You add your local LAN interfaces to Quagga as passive interfaces, and what that does is it lists them as networks that you want to announce or advertise without actually talking OSPF on them. So typically, you add your LAN, maybe a DMZ, whatever you want to advertise locally. And then when the two daemons will connect, they exchange that information. They say, hey, I've got these networks, and this guy says, oh, I've got these networks, and now they know how to reach each other. And on the global settings tab in Quagga, you want to add in a random master password. It's used by the status tab, but it also can be used from the shell. If you know your way around Quagga, you can connect to the console of it and poke at it and get status and run commands and things. Underneath that, you want to set your area ID. If you're not sure what that is, just use all zeros or 0001. It looks like it's formed like an IP address, just like I have shown there. You set your router ID. It's also like an IP. It's usually, it has to be something unique to uniquely identify this particular firewall. So its LAN address is usually what I put in there. And then underneath that, there's a section where you can list networks and what you want to do with them. You want to put the VPN tunnel network IPs in there with the /32 masks with that accept filter set that stops Quagga from accepting a route for those across the VPN. Otherwise, when you have multi-WAN, it can learn the route for one VPN tunnel network across the other one, and it can stop the VPN from functioning after a failover. So just need to make sure you don't get those bad routes back in that way. And then just once you've got that done on both the client side and the server side, you can go to the status tab. It should show you a full peering neighboring between them. You should see some routes. If you scroll down in those zebra routes in the status, you should see some routes tagged with an uppercase O to show that they came across OSPF. And if you do, you should be able to ping LAN to LAN and then do whatever test you need to do, yank a WAN or go through there. So that's it for those various styles. I had a couple more random bits that didn't seem to connect with anything else, but I wanted to make sure I mentioned. Some people have asked about, maybe a more of a true peer-to-peer style VPN similar to IPsec, and you can do that because in OpenVPN, your server can also be a client. It would only work, it's only really feasible with static key or SSL TLS/30 because otherwise it doesn't make a lot of sense to dial back to the client side. You need to set the local port in the client to a specific static port. Probably best if you make it match the server, like they're both on 1194, 1196, 1198, whatever. Your WAN rules on the client, you have to allow traffic into that local port that you specified. And then on the server, in its advanced options, you drop a remote statement in there that points to the IP of the client and that port number at a semicolon, and bam. They'll both try to initiate. And whichever one connects first, they'll just use that. And if one gets disconnected, they'll try that way or try the other way. It could be useful if you're in a scenario where you're not sure which side actually is able to accept incoming connections, so you don't know which one is better to use as a server, or maybe if they're both dynamic IP, or maybe if you had one as a server and it changed from a static to a dynamic IP and vice versa, and you don't know what you want to use, or you didn't want to completely reconfigure it, you can do it that way. It's just a little bit interesting little tidbit. Not a lot of people do that, but it's possible. And also, it's very inconsistent. Some clients, for some reason, remote access will get bumped off after an hour or so. There's a renegotiation timer in OpenVPN that you can set. It's just reneg-sec. It's not in the GUI yet. We're thinking about adding it in a future version. You can put that in the advanced options with a 0 on the server, which should should disable it. And you can set that in the client as well. And I'm not sure if you can push it or not. I haven't quite checked that. I've heard some people say you can't push it. And then that would stop the client from trying to re-authenticate after an hour or so. All right, so that's all I really had to go through today. I know it was a lot of stuff, and the presentation will be up for download very shortly. I'm not sure if it'll be yet today, and along with the video. not sure if the video come from views or from my, I've got a secondary recording going as well. But if we have any questions, you can either type them in or get them to me somehow. No, Carl, I'll take a moment and talk about your one-to-one NAT thing for the conflicting subnets. You really would you could either do that in outbound NAT, or you could do that with one-to-one NAT. Either way, one-to-one NAT is probably simpler if you're mapping a whole subnet over to a completely different subnet. If you had conflicting LANs, like say you had 192.168.1 on both sides, you would have to NAT both of them. You'd have to do NAT on the server side and the client side because they each would have to know to reach something different. So your server side could NAT to .2 and your client side could NAT to .3. And so when you're on the server side, you talk to the alternate client subnet and vice versa, and then that would work okay. You would, if you have not a direct conflict, but a secondary conflict, like say you have a VPN to some other site that has a conflicting network to a second VPN that you've got coming up, then the remote side of just one of those would need to do NAT on its way to you, so that the side that actually is connecting to both of them would not see a conflict. Just so long as everybody is seeing a unique subnet in each direction, you're good. So either we see that more with IPsec. We get a lot of vendors that push alternate subnets on people, or say you have to have a public address, things like that. But it's not very often you have to do that with OpenVPN. But there's a lot of use cases out there, yeah, where we still see it. Especially if you have quite a large deployment on a multi-site thing, if you've got a lot of overlapping or conflicting local subnets, you can map out a whole bunch of alternate ones internally, and so you know which ones go where, and have the other side do NAT, and that way you know what's what. Comcast subscribers with a default LAN subnet of 10.0.0.0. Yeah. The business gateways do that, I think. But if you have a static address, you can also use the static IP in the same thing. But if you have DHCP, you'll pull the 10 address. And a lot of the conflicting like that's pretty crazy. It's pretty common. I've heard about one DSL provider recently too that's doing something similar, and like with the Comcast Business Gateway, they absolutely won't let you trade that out with something different. So were there any other questions, or anybody else have anything they want me to go over in any more detail or talk about again? Or if not, I'll wait a minute here. I see, yeah, Carl's sending one in here again. Authentication best practices, such as integration with directory services. That's mostly a matter of preference. Tying it back to something like LDAP, Active Directory, Radius, it can be really handy for central authentication. It makes certificate management a bit of a mess, but some people will do authentication through that with no certificates for the clients. Or you can do it using both. It's just you have to manage the certificates individually on the firewall or elsewhere, and you end up it's just a little bit more complicated than it needs to be. Versus if you just have the local users defined on the firewall, it's pretty simple to add a user with a password and a certificate in just a couple of clicks. But if you document the process, you know what you're doing. It's not terribly difficult. In terms of LDAP and Radius in general, the only real best practices we have are, if you're using LDAP, make sure you're using SSL with LDAP. It's a little trickier to get going, but otherwise you're sending your passwords and such unencrypted. And if you're having to use a privileged account for your bind testing in LDAP, for actually checking the passwords, it's a pretty scary thing to be transmitting like an administrator password in the clear, even if it's just over your local network. So just put SSL on that as soon as humanly possible. For Radius, you can just go, as long as you got a sufficiently long shared secret in Radius, you're probably all right. And that goes for anything like OpenVPN or IPsec or anything else you want to tie back to that. And issuing unique certs to each locally defined user. If you are using, the ideal case is yes, every user should have a unique certificate if you're using certificates. If you're going to hand the same certificate to everybody, you may as well not even use certificates. You can change the authentication mode from SSL TLS with user auth to just user auth. Because if you have everybody using the same certificate, and then that certificate gets compromised, you have to reissue everybody a new certificate, and everybody's got the same cert anyway, so it's a false sense of security. It's not adding anything. It's just giving you a bigger headache. So every user should have its own unique certificate if you're using certificates. So I would go one way or the other. Either do full users with certificates and authentication, each unique, or just do authentication without certificates. As long as you use a TLS key, a shared key, it's reasonably safe. It's better to have more factors of authentication, but with the TLS key, you've at least got something else that they have that's not just a general use certificate. Unique certificates would allow the users to remember less complex passwords. Not necessarily. Again, it's a trade-off. You can have them use certificates without authentication. We see that it's a pretty common request to say, hey, how can I save my username and password in my VPN client? If you're going to let them do that, why are you asking for a username and password? It makes no sense. Just go with certificate auth without user auth and just give them a certificate and let them go that way. And if somebody is going to whinge about putting in a username and password every time, they may as well not have one. It doesn't really add anything for you. If they've saved it somewhere and that gets compromised, well, they're toast anyway. All right. Anybody else? Anything? Looks like I got one more. Carl again. Waiting on him to type. /24 OpenVPN tap networks, are they client isolated? I don't believe so. I'm pretty sure everybody can reach everybody. I think there is an option in the server settings that controls that. I'd have to double check. Give me a second. There is an inter-client communication setting that will allow them to talk or not talk. I believe that still works the exact same way on TAP or TON with topology subnet. I believe that's the case where they, if they are set that way, I don't think they get broadcast, but that's something I haven't tested that myself, so I can't really say with much certainty, but I don't think that works unless you have inter-client communication enabled. And Daniel just wanted to say thanks for doing the hangout. The first one they've been able to make it to. Well, it's nice to have you, Daniel. Thanks for letting us know. We like to do that. We're trying a few different things out to see if we can get them to where they're a little bit more manageable, a little bit shorter. I know we've had some pretty long ones in the past with a lot of detailed info, and we're trying to find a good way, a good happy medium where we have a decent amount of information with a bit more Q&A, and not such a lengthy thing. It makes it easier for people to get to them and make sure they've got time and can schedule around them. Yeah, that does make it a little more difficult. We have actually I'm in Eastern, so that's even more interesting for me because I have to remember I'm an hour ahead. And main office main office is in Austin, Texas, for Central Time, so all of our stuff is now in Central. So all scheduling everything else we do in Central. All right, so we're coming up on an hour here. So if anybody else has anything, I can take a couple, one or two more quick questions, or we can just call it quits. Going once, going twice. All right. I think we're done for this month. We still do owe you guys an extra hangout because we did miss the one in July got slid to August, and then we didn't get a second one in August like we planned. And it's a little late in September to do a second one now, but we'll try and get a couple in next month. So if you have any suggestions for topics for the hangout, you can post them on the forum or send them in. One way or another, just get them to us, and we're always looking for more interesting things we can do. So just let us know. And it's been a pleasure talking to you guys, and we'll see you next month.